Hi, welcome to this lesson on calculus derivative laws. Let's have a look at question 3. We want to evaluate the following derivative. So this entire expression prime, so that means derivative with respect to the variable here. In this case, the variable is x. So first of all, I notice these two terms immediately and I can't use any laws that I know because the power law says I must take the derivative of a times x to the power n. So you can see this x here is in the numerator of this expression, whereas x here is in the denominator. So how can I bring that x up to the numerator so I can use the power rule? Exponent laws. All right, so what I can do is I'm first going to write this expression. So I'm going to keep the prime outside. So I'm going to say it's negative 3 times x to the power minus 1, because that x has a power of 1 there. So I can bring it up to the numerator, right? And there's a minus 3 in the numerator. So minus 3 times x to the negative 1. Then 1 over x squared, I can bring that as plus 1 times x to the negative 2 now, if I bring that x squared term from the denominator up using my exponential laws. And then I have minus 2x and plus 3. Now I can use my derivative laws. I have a sum and difference in here, so that means I'm going to take the derivative of 3x to the negative 1 plus the derivative of x to the negative 2 minus the derivative of 2x plus the derivative of 3. So now I can use the power law here. I bring this exponent down by multiplying it, so it's negative 3 times negative 1. So watch your bracket placements as well, because you're multiplying two negative numbers together, so you don't want to lose track of those pesky negative signs, right? And then you have x to the power negative 1, and then we subtract 1 from the power. Okay, so that's the power rule. Plus, now for this one here, we bring the exponent down again, so it's going to be negative 2 times x to the power negative 2 minus 1 from the exponent. Minus, okay, so I put my derivatives here. The derivative of 2x, remember x has a power of 1, so it's 2 times the 1 times x to the power 1 minus 1. And then lastly, from the constant law, the derivative of 3, which is a constant, is 0. Okay, so let's do our algebraic cleanup. Negative 3 times negative 1 is positive 3. X to the power negative 2, right? Minus 1, minus 1. Then I have plus negative 2, so it's minus 2 times x to the negative 3, because negative 2 minus 1 is negative 3. Minus 2 times 1, and then x to the power 0 here is just 1. So it's just minus 2 times 1. So I have 3x to the negative 2 minus 2 times x to the negative 3 minus 2. But again, for convention's sake, we don't like keeping negative exponents. So how can I get that negative exponent to be positive? Well, I can take it to the denominator by my exponential rules. So it's 3 over x squared minus 2 over x cubed minus 2. All right, and that is the derivative of that extremely complicated looking function. But imagine if we had to use first principles here. What a nightmare, right? So thank goodness for those derivative laws, because it makes the calculations that much more simple. All right, so that's how we would do this type of question. I'll see you in the next one.